All right, how about now? All right, I apologize to everybody from outside. Again, I'm Dr. Molnar. There's Dr. Steve Crowley in the room. We are the hosts of the MaResoneX seminar. Welcome to the seminar and welcome to the classroom in here. I quickly go through the procedure. After the introduction of the speaker, we'll have a 40-minute talk, and after the talk, 5 minutes of discussions at the tables. Those joining us on Zoom, you're welcome to join the breakout room in Zoom to talk about the discussion problems, or just stay in the big room. And after those 5 minutes, the presenter, the speaker, will be ready for questions and answers here in the classroom or online. Okay, and with that, it is my great pleasure to introduce Mr. Christopher Longton today. Mr. Longton is a consulting geologist and industry professional involved in all stages of mineral exploration, a graduate of Illinois State University and a field geologist at heart. He has experience from greenfields exploration to production on precious and base metals deposits throughout North America and Australia. His experience has led him managing large-scale projects, most recently as Vice President for Exploration for Hercules Metals, where he was intimately involved with the Hercules porphyry copper discovery in Western Idaho. Mr. Longton is a discovery-focused geologist who believes in integrating new technologies into existing projects without losing the time-tested skills which have made the majority of discoveries to date. He is also keenly interested in revamping the image of the modern miner and highlighting the great distance mining has grown. He will talk about mineral exploration methods, discovering the first link in the supply chain. Please help me welcome Christopher Longton.
Hello, thank you very much. I appreciate that lovely introduction, and thank you, Doctors Molnar and Crowley. Thank you, students, and everybody else who's sitting in on this. And I'm terribly sorry that I'm unable to be there in person today. Unfortunately, the weather was not accommodating a trip over the Blue Mountains yesterday or today. And it's a real shame. I had all sorts of great stuff. There were fireworks. I had kegs of beer. I was going to hand out gold bars to everybody. You're really missing out not having me there in person, but I'll do the best I can from afar. And I'll try to keep it interesting, and hopefully we'll have a good time along the way. All right. Yes, again, the discussion is on exploration methods and how we find the things that we find. So, what is exploration geology? It's geology. Exploration geologists, we're just geologists. We're earth scientists. We study the processes which lead to mineral deposits, and we locate those deposits. There's an economic component to exploration geology. There's a lot of components, it turns out. But explorationists all start out as geologists. We all branch out according to our skills. But I like to say that, exploration geology is what gets us from this, which is rocks, to this, pipes. Indoor plumbing, infrastructure. Oh, and this, no part of your phone was grown in a field. We've got cars, solar panels. No part of a solar panel was grown in a field. In order to have solar energy or any type of green energy, we have to have mining. All of our modern medicine is impossible without mining. Farming, the old saying is, if it can't be grown, it has to be mined. Except even to grow it, we need to have mining, because no part of this tractor was grown anywhere in a field and hand reaped and with wooden and stone tools. We need all of the things that come out of the ground. Our modern cities, every part of a city owes itself to mining. And space exploration, all the components of that space station started with some knucklehead like me breaking a rock with a hammer. And they make their way up here eventually. I'm going to talk mostly about copper today. We're going to actually do sort of a scenario where we're going to look at possible a copper project, and we're going to walk through the steps of what it would take to actually get that project up and running. It could be for anything, but I just like copper. Copper rocks are beautiful. If I was there, I would be showing you a bunch of copper rocks that are just gorgeous. That is true. You're not missing out on that. Or you are missing out on that. But every aspect of our modern life is tied in with copper. We have no electricity. We don't have any sort of the infrastructure that we need to develop our modern world without copper. And it's critical to every part of our lives. I'm going to touch on this very briefly and a little bit more down the road, but it's the life cycle of a modern mine. Now, can you see my laser pointer thing there? Hopefully. I will assume yes. Exploration is the first stage. This is where I'm focused. After we find a deposit that theoretically could become a mine, it has to be designed. When the designing is being done, it isn't just, you know, the pit design or where the buildings are going to go. It's every part of it. During the mine design phase, we have to be thinking about reclamation. So you have to think about the end before you even break ground to start your mine. Then the mine goes into construction. That's where you have 800 to 1,000 people staying in camps and building the thing. There's a lot to build. It isn't just a modern big mine. It isn't just one person with an excavator. Then you get into production. And the production length is determined by how much mineral is in the ground, how much that mineral is worth. So if it's gold and it's $2,500 an ounce, that is a lot different than gold at $200 an ounce. You can mine a lot more when it's more expensive. When the mine's wrapping up, you have to have a closure plan and then reclamation. Exploration seems like it's just the first part of this, but I've been a part of exploration programs all along this process. I've been a part of exploration programs that mining companies, they want an exploration program to begin at construction. And I've been at some where after reclamation, we went back in because the metal prices were so much higher than they were when the mine closed, and they wanted to reopen the mine. So exploration takes place all along during production. It's brownfields exploration. I'm going to be discussing that a bit further on in the talk. But every ounce that comes out of the ground, your company shrinks because these are non-renewable resources. Okay, the exploration pipeline is people that are completely outside of the industry have no idea how any of this works. People that have a cursory understanding of the industry think of it in this sort of a way. And it's the prospector is the first person involved. They find a claim, they stake it. Then you have a junior explorer. That's a junior exploration company, and they'll typically come in and purchase the project from the prospector, and they'll try to expand on it and then sell it to a mid-tier or major mining company. The designation there is one based off of market cap, and it just has to do with how much money the companies are worth. And bigger companies are majors, and smaller mining companies are mid-tiers, and the really small ones are juniors. The work breakdown, the understanding is the prospectors stake claims. They do some initial assaying where they'll take a couple of rock samples and they'll send them off to get just some sort of official number. They'll shop around the property to different people, and they only earn money by selling the property. And your junior explorers, they are your early stage exploration. They'll do some mapping and sampling, maybe a little geophysics. I'll talk about all of that in a few slides. They'll drill as much as they can. Drilling is very expensive. They'll also shop the property around, and they earn money by selling the property or the company. And then your major mining companies, they do resource definition. I'll talk about that as well. I'm just showing my hand here, but we'll discuss that when I get into block modeling a little bit. But that's trying to understand how much is really there, because you don't know. It's all going to be an estimate about how much mineralization you think is there. They typically handle permitting, they develop it into a mine, and then they earn money from the mineral. So when gold costs $2,500 an ounce, they're the ones who get the $2,500 for every ounce. And then the cost just keeps going up from there. The reality is that prospectors are often very savvy, and they are involved in a lot more than just staking claims and taking a couple of initial assays. Sometimes that's all they do. But I've seen prospectors work with drilling companies and actually poke a couple of holes in the ground themselves. I've seen some that really understand what's going on, and they do some mapping and proper sampling, getting aerial photography done. I've known some miners that if it's very small scale and very high grade, they mine it themselves and they can make a little bit of money from that, and instead of shopping it around. The junior exploration companies, I've seen do resource definition. I've seen them, get into the permitting side of things and even do the mining. So these really small companies might own one mine, maybe even two mines, and they can make the money from the mining or from selling the company or property. And the major companies also, aside from some of the things I talked about doing, they'll do brownfields exploration. Like I said, every time you take 1 ounce out of the ground, your company shrinks. And they do the development, but I've also seen major companies selling their projects and properties. Sometimes they hold a huge portfolio of properties and they're constantly doing exploration on it to make it look good so they can spin it off and sell it to somebody else. And so then they're earning money from the minerals or from selling the properties. All right. I'd like to go back in time a little bit, talk about the history of exploration just a little bit. We'll just step a little bit back in time to about 3000 BCE. That's when we got a good understanding that mining on sort of a larger scale really began in Egypt and China, roughly around the same time. When we have references to the Golden Fleece from ancient Greek writings, if you think of Jason and the Argonauts going after the Golden Fleece, what that really was, there really were golden fleeces. What they would do is they would take the sheepskin and lay it downstream in a river. And then they would work the stream beds and loosen as much sediment as they could, and it would flow over the top of the fleece, and any of the gold that was in there would get collected in the wool. And then they would take, when it was loaded up, they would drag these things out of the water loaded with gold, and they'd just let them dry, and then they would shake it out, right? There's history to the mythology behind some of these things. In the medieval and Renaissance times, De Re Metallica was the seminal mining text. It came out in the 1500s, I believe, 1400s, 1500s, and it was the text that described everything about mining knowledge at the time. To get it, the author had to go to a number of mines, and this was in what's now Germany, so it was Holy Roman Empire and the German states at the time, and would go through and meet with all of these miners who kept the secrets of what they were doing. It was closely guarded secrets, because if you had, it was a technology that other kingdoms really wanted. And the only way he was allowed to publish it was in Latin. So theoretically, only learned people would be getting the information. Now, in time, it was translated into German and French, I believe, after that, and then ultimately into English. At that time, the Spanish were mining in the Western Hemisphere. The conquistadors, they were learning from the indigenous people techniques that were gathered through their colonization, but also they were taking some techniques from Europe to Central and South America and bringing techniques back with them. So there was an exchange of knowledge there. And then in recent history, we think of exploration as prospectors. I recommend to everyone read the short story All Gold Canyon. It's by Jack London. I think it's like 5-10 pages long. It's a short story. And in it, he describes a prospector and the method that was used to do prospecting. And it was completely accurate to how people would do it. They would pan up a stream until they ran out, until they quit getting showings of gold. And then they'd go back to where the showings dropped out and work their way up a hill until, again, any gold showings quit showing up. And then the last place where they had actually panned a little bit of gold, they would start digging there and hope to find a big vein. And the way it's described is really accurate. And it's something I actually, we go back to a lot of old mine sites and do work and do modern exploration at these old sites. And I'm always working with my young geologists saying, think about what had to have been done to put a hole in the ground here with mules and dynamite. They did it because there was a reason for it. So it's worth, exploring and trying to understand. But we also think about the gold rushes, the California, the miner 49er and all that business when we think about exploration. Modern exploration has come leaps and bounds from there. So what I'd like to do is walk us through a hypothetical project. We'll go through the steps of turning a prospect of somebody who is a rock hound into a successful working mine. And to begin with, I would like to say that we are going to beat the odds in this. The chance of success for an exploration project turning into a mine is 1 in 3,000. So the stakes are high, and the chance of failure, if you can't accept that you're going to fail more than you'll succeed, then don't get into exploration geology. But prospecting. So again, we picture the old prospector with the big hat, the scraggly beard, and the mule, and gold, gold, gold. But the reality is, most modern prospectors are really savvy, and most of them are actually doing a lot of work. They're keyed into the systems. They've got to look up all the claims online. They've got a good understanding of rocks and geology. A lot of times I've met prospectors who don't know the right technical names for everything, but by God, they know the relationships that all the minerals have when it works. So let's say for our story here that someone in this class, their family likes to go hunting, and that person in this class, maybe they like hunting, maybe they don't, but they love rocks. So they always go out with the family and they bring a rock hammer. And one day while they're on some BLM public land, the family goes off chasing deer, and our prospector takes a hammer and they break a couple of rocks and they find copper oxide. Copper oxide stands out like you can't miss it. If you think about the Statue of Liberty, you've got that green-blue patina, and that's what copper oxides look like naturally. And they see some of this stuff, and let's say, okay, well, that's great. And they break some more and they find it all over the place, and they go and they stake a 20-acre claim at the BLM office. They go bring out some posts and stake the claim. All right, then they start going out and they start breaking some more rocks, and they find even more, and they decide to stretch out their bank account, and they stake 20 claims, which is huge, and each one's 20 acres, and they cost $200 a claim. And the assays are about $40 an assay. So it's already starting to add up, and it's a lot of money for one person. And it's their hobby, and let's say it's all that they really get into. But if they know some geologists in junior companies, they met at trade shows or just at rock shows or whatever, they start talking. And in our scenario, our geologists get pretty excited about this. They've got a little bit of money. They want to form a company. But if you want to list your company on the Toronto Stock Exchange, Toronto Stock Venture Exchange, which is where you list your junior company, you have to have a property. So they make a deal with our prospector. Our prospector has just cashed in. Maybe they got a couple $100,000. Maybe they got tens of thousands of dollars. Maybe they just got a whole bucket of stock from the company and they're going to be involved a little bit. Any type of deal can take place. But now our junior miners in, and this is where they really get going. Because let's say they've got, $5 to $10 million in assets, then they can do some work with it. They're going to start out with soil samples, right? I would say that, in this scenario, they would immediately stake a larger land package. They would stake as many claims as they could around those initial claims and try to get 5,000 to 10,000 acres, right? Because if you ever want to get picked up by a bigger company, you need to have a good sized land package. And then they're going to plan a soil sampling grid. And you can do this at any spacing. So commonly you'll start out at like 350 or 300 or 200 meters and get an initial grid that way. And then you sort of work in areas where you need more definition. All a soil sample is somebody with a shovel or a hand auger digging down to a predetermined depth based on the type of geology and deposit, if it's a glacial terrain or if it's high desert or whatever, or what type of mineral you're looking for, if it's gold or copper or silver or whatnot. And then they dig a little hole in the ground, usually 6 or 8 inches, scoops the material into a sample bag, and then they move on. A good sampler is going to take about 500 or about 50 samples a day. So with our 5,000 samples at 50 samples a day, you get 3 people out there. It's going to take them about a month. Let's say we have a creek on the property as well. So we're going to take some stream sediment samples. That's where you take samples in specific places in a creek or stream that have a high likelihood of getting mineralization to settle out. It's more common in gold, but I've used it in copper projects as well. And you look for areas where there's a confluence of 2 streams. You look at areas where there's a big rock and you've got sort of a calm spot behind it where anything that's in suspension in the water has a chance to drop out. This is a soil grid from one of the companies I used to work for, and there's all just sorts of things you can do with it. We used it to highlight where copper was as we were trying to sell the project and interest other people. Then you have mapping and sampling. Now, I'm a field mapper by training and background. This is where we go out with a rock hammer. You have your notebook, a sample bag, a compass, you got a hand lens, which was on me when I took this picture, so it didn't make it into the picture. We make geological maps where we try to understand the rock type, if it's a granite or limestone or whatever, but we also try to understand mineralization. So if there was minerals that were emplaced there after the rock was already existing in that spot, and alteration. And I'm sure everybody knows the 3 basic types of rocks: igneous, metamorphic, and sedimentary. There's a 4th that doesn't really get talked about too much, and it's a metasomatic change to your rocks. So in a metamorphic rock, you completely change one rock type to another. In a metasomatic change, you change the minerals in a rock type, but it doesn't change the rock type. So your granite is still a granite, even though your plagioclase all becomes epidote. And you do that alteration with heat, hot fluids, acidic fluids, a lot of pressure. Any combination of those things is going to lead to alteration changes. But we have to map that because they mean different things. And minerals will change according to the temperature a lot of times, or acidity. And we want to be hot and really acidic to center in on the heart of a system. So we have to track all that. I do it on paper, where I go up to an outcrop and I draw the map, and then take a bunch of notes in my notebook, a bunch of photos, grab a sample. I then take my map, I digitize it to make a geological map in a larger format. And you can do all of this in one step with digital mapping, and you do it all on a tablet. In fact, you can just take pictures with your tablet and you make the map and you put your notes right into your tablet as you go. It's very fast. The reason I use the paper mapping is it forces me to make that connection between hand drawing a thing and thinking about it. I have to think about everything I did that day again when I type my notes in, and I think about it a 3rd time as I'm digitizing my map. And it's a system that forces more thought and introspection, but it's considerably slower. So there are trade-offs with everything. It's also really dangerous sometimes. Just really quickly, I've had bear encounters, scorpions, rattlesnakes. I worked in Australia with a bunch of Australian snakes. I've had to deal with angry moose. I slid down a glacier one day and almost broke both my legs, and then had a bear encounter where my partner and I got stalked by a grizzly up in Alaska. Fly around in helicopters a lot. There's generally at least one death a year in exploration in Alaska from a helicopter or a small plane going down. It can be very dangerous work, but I don't know, it's fun and it's exciting and exhilarating. There's other things that we do as junior mining companies. We'll get ortho photos. We'll do LiDAR imaging. LiDAR has become key in understanding the landforms, and we're able to understand landslides and structures a lot by looking at our LiDAR data. And geophysics is a huge part of what we do because we need to be able to see under the ground. And how do we do it? And it's through a lot of different geophysical surveys. Magnetometry is one of them. You can have land magnetometry where you have one poor soul with a backpack walking a perfectly straight line no matter what the terrain is like. And I've been that poor soul, and I've seen clearings 20 feet to my side, and I couldn't go over to them, and I just had to keep busting brush or going down off of cliffs or anything. It's miserable. There's drone magnetometry, which is faster. They put the magnetometer on a drone and they just fly the lines. It's limited by, you got about 20 minutes for battery packs, so they're constantly changing the batteries. Or you do it off of fixed wing or a helicopter where you put the magnetometer on and you fly big lines for kilometers, which is really expensive but very fast. What this picks up is any really iron-bearing minerals in the ground tend to get highlighted. You'll see it if there's a big magnetite body, or a lot of times your structures really pop. So if you've got, these are probably faults that we're looking at here. IP and resistivity, induced polarity and resistivity. We lay out wires across the ground for kilometers at a time. Then you charge the ground for about 3 seconds, and you look at the response that you get at which areas are more conductive and which are more resistant. And if you have a lot of metal in the ground, it's going to be more conductive, but it's not the only thing that makes things conductive. Some clays are, some aren't. So there's a lot to that, but it can tell you a lot of information. Let's see, gravity surveys. That's another one where you're measuring the gravitational acceleration at the Earth's surface to understand subsurface density variations. That can be very important if you have dense minerals. There's radiometrics. Again, you'll fly detectors over an area and you'll look for any radioactive signature. They'll usually test for potassium, thorium, and uranium. And those are really important if you're doing sort of like a copper porphyry deposit, like our example, we're looking for a big copper deposit. They tend to have potassium in their minerals at the core. And so you really want to find that potassium. And seismic is the last thing I'll mention here. There's a number of other methods, but these are kind of the main ones people use. And here you create a shock wave and you have geophones set out at various distances to pick up the vibrations as they come back. And you try to get this picture of the subsurface. It's just waves. Geophysicists are magicians. I've seen that plenty of times where they're just looking at squiggles and they tell you what everything is. Sometimes they're right, sometimes not. But this could be showing us some landforms. You could have a basin or something here in this instance. All right. So let's say you've done all of your sampling, you've done your mapping, you've done your geophysics. Keep in mind that the geophysical surveys cost in the hundreds of thousands of dollars range. Every sample that you take in the field is going to be about $40 to get it assayed. You've got the geologist whose time is going to be $500 to $1,000 a day, depending on how experienced they are. You've got field assistance, you've got helicopter charges. This is very expensive, and you haven't even put a hole in the ground yet. So when you want to put a hole in the ground, you drill. And people talk about drilling, and they say, drill, baby, drill, et cetera, et cetera. And this is the image I think a lot of people have in their minds. But this is not what we do in exploration. This is a drill rig for oil production where they will drill miles into the ground, right? This is what we use. So this is a very typical exploration rig. It's on tracks. They can move it themselves. It goes about 2 or 3 miles an hour. You get core from it. So I was going to bring in a core, a drill bit, but this is what the drill bits are. You see, it's a cylinder that's diamond impregnated. This is called diamond drilling because you have a diamond impregnated cylindrical bit that cuts into the ground, and you break off a cylinder of core. We orient that core because this could spin around in the core barrel and the drill, and we wouldn't know what the orientation of like this vein would be, right? So what we'll do is we use a machine that has a gyro on it that tells us where the top of the core is, not the upper part there, but actually the top of that cylinder of core, because otherwise this could be any plane in a 360-degree cone. And by measuring that, we know where it is, and we can place it in space, and then we can try to trace it out along what we call a long strike. But if you're going to do core, it's expensive. You're talking $100 to $150 a foot to drill that just in the direct drilling costs. You also need a core shack and a logging facility and a geologist to log it. Another common method is RC. These are not the only methods, but these are the 2 most common, and that's reverse circulation. And what they'll do is it's a hammer that pulverizes the ground. These are 1-inch by 2-inch chip trays. So when you think about the cylinder of core that we had in the last one to try to understand the geology, this is all you get to describe 5 feet of drilling. Instead of having core that needs to be split and sampled, it just comes out in bags like this. The rig's a little bigger usually, but I've seen some that are smaller. Usually need a water truck, where the core rigs, they can work with water pumps a lot of times, but otherwise this is really fast and inexpensive, but this is what you get to work with, which isn't always great. All right, so once you get your stuff into the core shack, then we have to do something with it. In your core shack, you have a whole team of people, and you're going to have geologists and geotechs. And the techs, so in my core shacks, wherever I work, nobody's too good to pick up a box of core. And so everybody puts the core out on the tables, and then the jobs split. This is the flow chart from one of the jobs that I was on, but it's not the only way to do things. This is just going to be an example. Here, the geotechs had to start measuring the RQD. If we have any engineers in the audience, you may be familiar with this, the RMR equations. It's rock mass rating equations. There's 2 main ones. Each one needs 5 different variables. And we want to make sure that we collect the right information so that it's useful. The geotechnical engineers that are going to look at these data are hopefully going to be planning a mine. Now, this is way before there's even knowledge of a deposit there. We're poking a couple holes in the ground, hoping for the best, but we're still going to be thinking about this down the road. And their biggest worry is always going to be failures. And is the mine going to collapse, or is a wall going to fall down? And they need to understand how broken up the rock is. They need to understand what the different joints are like and what sort of coating they have on them. And anything over 10 centimeters, we measure as having rock quality. You look at how much core was recovered, how much rubble and gouge. We count how many fractures there are. You'll hit the rocks with a hammer to try to determine a hardness and a rock strength. We can understand the joints, and you'll track and log how rough it is or smooth, or if it's got clay on it, things like that. At this project, we did specific gravities to try to understand density changes in the rocks. And then our geotechs will do, at this job, we did spectral scanning, and I'll talk about that shortly. You take high resolution photos, you need really good pictures, especially we're starting to move towards AI tools with exploration, and you need perfect photos for that to actually work. And then the geologists, while the techs are doing all this, are logging the core. So they're taking these rocks, they're looking at them with a hand lens, and they're tracking what type of rock it is, how much mineralization is there, what are the alteration minerals, how broken up is it, what structures do they see. They'll measure the structural features, they'll put in sample tags for the rock to be sampled at various intervals, and then you'll have someone who goes in and they cut it by hand. There are automatic machines. They're $40,000 each. This saw is about $5,000. So on small junior projects, this is what you get a lot of times. And you get out there and you got somebody who, in any kind of conditions, they're covered in rain gear, they've got the face mask, the ear protection, and they're cutting these rocks in half. But then you get these samples. This was a record day for this gentleman, who's actually the mine manager at a mine in Canada right now. He's moved up the ranks in the last 12 years. And all of these samples will get shipped off to an assay lab to understand what's in them. Some of the additional stuff that we can do, you've got, these are scanners. The spectral scanners are high-powered flashlights. Picture any hydrous mineral from chemistry class. You've got that OH molecule hanging off of there, and you hit it with a flashlight and it wiggles, and the frequency, the wavelength of that, the way that it bounces the light back, is tracked, and it's different for each mineral. And so that tells us, we can paint a picture actually with that. This is an XRF, an X-ray fractionometer. It's an X-ray gun. It can tell you elemental concentrations. This is a core scanner that does all of it. High resolution photos, XRF scanner, logging, everything you can imagine. Collects a terabyte of information per meter. And with that, who needs a geologist? We can talk about that afterwards. And then we'll do slides. We'll do thin sections to look at the rocks at a micro scale. After we've done all that, we do two different types of models in general. One are geology models. This is a lithology, but we can also model the alteration. We can model mineralization and structure. This is the other part of what I've spent my career on, is mapping and modeling. This is a block model, and this is how we estimate the resource involved in the deposit. And each one of these blocks has a value based on the drill holes around it. And so you have to have a certain density of drilling, and it's different on every project, to say we have continuity from here to here, and we can estimate that the grade in this area is going to be, this one doesn't have a drill hole through it, but they say it's 1.2%, right? Copper. And, or 1.2 grams gold. I think that's what that one would have been. But this is resource estimation, and it's a tricky business because it's really a guess. And you can either have measured, which is the highest confidence, indicated, which is middle, or inferred, which is pretty low confidence. All right, Eureka, we beat the odds. We beat the 1 in 3,000 odds. We made a discovery. We poked a drill hole into a porphyry deposit. We're all excited. Everything is amazing. We got millions and millions of dollars to spend. And now I realize I'm running out of time, so I'm going to go pretty quick through these. To actually get into your mine, you're looking on average of 13 years in the US. to get through the permitting phase. The permitting is the NEPA phase. It's the National Environmental Policy Act. It's an umbrella act. It's different on every single project. But as an explorationist, I've had to be involved in gathering a lot of the data that's required to get through this process. And the Lassonde curve. Very quickly, as a junior miner, we only make money through our stocks, right? And the major companies, they're all living up here. But the junior companies when we bought it from our prospector, our stock price was down here at 10 cents. We made a discovery. It shot up to $1.50. And as we went into the permitting phase, then our stock went down to 40 cents. And then as you get closer, it goes back up. And this is just how we make our money in junior mining, is with our stock price. So it's very important to understand that in this permitting phase, your stock price is going to dip. All right, production begins. A major miner is at it. They're doing stuff. What happens to our exploration team? Well, we still have to do more exploration. There's brownfields exploration where you're trying to find more. You're watching the commodities prices. If your commodity price goes up, then things that weren't economic before become economic, and maybe an area you didn't explore previously, you have to explore. And so our explorationists have always got to be out there working through the life of a mine. And like I said, even at the end, sometimes you've got to go back to a completely reclaimed mine and reopen it up. All right, and this is for our philosophers. I am a big fan of Albert Camus, and The Myth of Sisyphus is an essay I recommend everyone read if you haven't already. But it's the thrill of exploration versus the likely futility of this endeavor. Why do we keep doing this? This is the system that's in place currently, right? What sorts of disruptions are going to upend the current model in time? I don't know. But there is so much stubborn hope in the human heart, and there must be, for us to keep going at this 1 in 3,000 chance of success endeavor. All right, thank you very much. I think that is our 40 minutes. We're pretty close.
Is fantastic. So let's first of all give a thank you to our speaker. Thank you, Chris. And for you now, we'll have a 5-minute break. And there are the discussion prompts here for the classroom. Also, back from remote, you have the opportunity to join. No. What is that? You don't. I need to put it in front. Can you come front, please, and help me here? So we'll open a breakout room for those who would like to. We create one breakout room, and you can self-assign yourself to go there. For those who are students in the class, please join the breakout room and discuss the discussion prompts. And then we'll reconvene in 5 minutes. And here in the classroom, we'll do what we always do in our teams, sit together, read the prompts, and start talking. Right, we are back in the classroom, and I think also the Zoom room has closed, and we have our speaker back here. Chris, if you would like to share your slides again, I think they stopped sharing in the breakout room session. That would be great.
All right.
Good. So let's hear around here. Who would like to start us off with a question? Yes, here in the front we have one. All right.
Promise the question.
We were wondering with like the social license process, for one, like how much of a formal process is it to earn that social license, and how early in that like exploration process do you have to start considering earning that?
Yeah, immediately you have to do it. There's no formal process. Everybody kind of does it the way that they can. The last project I was at was with Hercules Metals. We were near Cambridge, Idaho. One of the things that we did was we were there for a year doing some work. Nobody really knew we were around. By the second year, everybody knew about us because it's a small town and they kept calling us the miners, even though we weren't mining, we were exploring. But, you know, that's a semantic difference. We got out and we were having town hall meetings where we had 250 people from the community came out one night, and I call them piñata meetings. They string me up and everybody takes a swing. And I had to answer some very tough questions. Those actually are on YouTube. You can look them up, the Hercules Metals town halls. There were 2 of them that we did. You need to have engagement with everybody, though. One of the problems that we find a lot of times is that you'll have, we were talking about this in our breakout room, the sort of push-pull between the ethics of mining in the States. There are groups that don't want any mining to take place at all because it can leave a scar on the land. And if you don't do it here where we've got strict regulations, you're doing it overseas in places that maybe don't. So I don't know how a person like calls themselves an environmentalist by shutting down a mine here that has to go through a very strict process to then support mining by default in a place that doesn't have that. And we need to get out there and to build the mine. You'll often have local community support, but then you'll have an NGO from a different part of the state or from a different state entirely that comes in. They put a lot of money in to try to stop the mine. And you really need to work with your regulators. You need to work with the community, and you need to do your work in the best way possible. We had a situation with that company where I was, where we intersected water with one of our drill holes, and there was a potential that it could have gotten into a creek. So we immediately shut the drill hole down, did everything we could to stop it, but we reached out to our regulators right away so we could talk about it. And then they came up in the town hall that we were having, so word got out into the community. But it's something that we're always working with. And you saw the footprint that we had for our drilling. It was pretty small. Sorry, I'm going to take all our time going on with this one question, so I'll stop now.
Thanks, Chris. You folks are better at holding it far away than I am, so.
Hello, my name is Jade. I had a question about, because this is isn't the first time we've heard that the US is particularly stringent on mining and regulating mining. I'm pretty sure, correct me if I'm wrong, did your presentation say that our time length for mining permitting is actually a little bit shorter than average? And how does those two things, they seem to contradict each other. So I'm wondering if maybe there's some context that we're missing, or yeah, so the worldwide average 15.7 years, ours is almost 3 years shorter, which would give another 3 years of profit. So on what basis are we saying that ours is more stringent? Is it the permitting requirements, or is it strictly the time length itself of how long mining takes?
Yeah, that's great. There are so many variables that play into this. Unfortunately, with this 13-year time frame, it's with all mining. And in the States, we don't have a whole lot of the biggest types of mines in the world. Those are the porphyry copper deposits, and it gets skewed by Chile and Canada for their permitting time because they're just these massive deposits. We have some, but it's a much smaller number. We also, this takes into account some of the things like different types, like the aggregate mining and things like that in the States. I've heard numbers where they say on average you're looking at 20 or 30 years, but this was what I came up with. In some places, you're also dealing with things like government corruption in a way that we don't have here, where you're going to get government interference by local officials that are looking for handouts. You're going to have other places like in Brazil, where you're going to have a lot of indigenous communities that are slowing the process. So all of these things go into what takes the time, and it isn't just the permitting, right? If it was, and I think our permitting system is a mess, right? And on my next slide here, those are two completely different projects. The one on the right is a mine. That's Perpetua, that everybody around here should know about. The other one, that was a road project from like, I think it was Mississippi, that they had to do this. And it wasn't even a mine, but it still fell under NEPA. And there's completely different things for every single project. So to me, that's a thing that needs to get sorted out. Sorry, I guess I'm rambling around a lot, so you'll have to forgive me with that. There are a lot of variables that go into it, and the environmental impact is one of the variables. The politics, the people impacted, the perceived impact. In Canada, it's well known that the more resistance that people have to a project, the more the company will pay out to get the project pushed through. And I mean, that's very common in Canada, and I've seen that a lot of times. So it gets tied up in litigation for a lot of time. But for us, we have to follow the Clean Air Act, Clean Water Act, migratory birds. I've had jobs where I couldn't drill at certain times of the year because there was the potential that migratory birds could be coming through. I worked at a mine where we spent $1 million to relocate any fish that were going to be in the immediate footprint of the mine. And well, I'm sure they missed some of them, but they did everything they could. They got all of the fish that they could, and every fish that they were able to trap were minnows, but we still had to do it, right? And because it was a living thing, and we had to, those stories don't get out into the general populace. But yeah, it's a lot of variables go into the time on it. Hopefully that answers your question.
Yeah, thank you.
Thanks, Chris. Two more.
So you're not directly connected with the larger mining companies. When you're like doing like outreach with locals in an area, when you're in the middle of this exploration, what assurances can you give them about the reputation of the larger mining companies that end up taking over those sites? Like, do you have certain companies that you have like in the back of your mind when you're selecting these locations and exploring them for who you're going to kind of turn them over to?
Oh, no, I wish I had any control like that. No, they hold all of the control, right? It's whoever comes to you and wants to buy your project, if they want to buy it, right? At Hercules, we were lucky because we had a major discovery, and we had 6 major companies knocking on our door within 10 days, which is almost unheard of. And we were able to pick and choose who we wanted to work with by having the best deal. To answer your question, there are no assurances that I can give to a local community about what's going to happen if a major company takes over. All I can do is get to know the people in the community myself. I look at Cambridge as a great example of that. I couldn't walk 5 feet down the road without getting stopped by 2 or 3 people and having a conversation. And I welcomed it. I loved it. And I got to know everybody. Barrick, the second largest gold producer in the world, invested $23 million in our company. And everyone had the exact concern that you just brought up. And I can't speak to how they were going to do things. And what we ended up doing was getting Barrick to do a town hall meeting. And they met the community and they talked with them themselves. But yeah, we have no control whatsoever about the major companies. I know who I like and respect and who, like, okay, we're always the bad guys in the movies, right? Watch any movie, and if there's miners, we're bad guys. Look at Avatar. Look at anything where the miners are always bad guys. There are mining companies that earn that reputation. They're companies I won't work with, right? And I'm not going to say their names now because I don't want to get sued for slander. But you know, Barrick wasn't one of them. I felt good about working with those guys. But yeah, you just have to get people out in front and have people meet each other. I always say nobody is the devil when you can sit in front of them.
All right, how we go? Oh, excellent. We've got more time.
Hello, my name is Mark. I've got a question on the AI side of things.
Yeah.
I don't remember what that machine that you called in your in the speech was, but it was some device that could analyze a terabyte of data. And the question is how do you analyze that much data at all? What do you do with that kind of information? And then how do you see artificial intelligence affecting your field now and in the future?
Yeah, no, I appreciate that. So that's a core scanner, and it basically picture a shipping container, and they mobilize it out to a site, and they'll run it through, and it collects a terabyte of data per meter, every meter of core. And you figure I've drilled kilometer deep drill holes. I've drilled 2 kilometer deep drill holes. So getting that much data it's a lot. So how do you analyze it? Well, a lot of it's done by the machine. And then theoretically, you have a team of people that are looking at the data. We're getting into a point where they're starting to develop AI tools that are looking at the data and trying to be predictive about places where we might have deposits or where targeting for drill holes might be beneficial. And it's very tricky because even with the core scanner, if the core isn't set up just right, it doesn't get good readings. If the core's wet, you get a bad reading with the spectrometer. If it's dark core, the spectrometer doesn't work with it because you don't get the spectral signature with it. The XRF is going to tell you your elemental abundances, but it doesn't tell you how they're configured. And having a bornite as a mineral is different than having chalcopyrite as a mineral, and it tells you things. So we're getting to a point where people are starting to use these tools. To talk to them, they'll tell you it's the best thing in the world. I've tried a few of them and they aren't. A lot of the data that we have in industry is private. A lot of it has been poorly collected over the years. You get incomplete data sets and you get sometimes questionable data. So it's hard to make a good model with that. Where they're doing it sometimes is their test samples, or they're going to a known mine and they're putting in the data after they've gotten they're mining it and they know the deposit's there, and they're trying to train the tools that way, and see if they could get all the information and then predict that the mine would be there, sort of a thing. It's a thing that'll come up down the road. It's going to unfortunately put a lot of geologists out of work. And I say unfortunately because when I talk to the people developing these technologies, they say that it's great for geologists because it frees them up to do more interpretive work. But if you don't have the time in actually learning about it firsthand, then you're not going to be very effective at interpreting the data in a meaningful way. And so it's a challenge that I think is going to create a reckoning in the industry in the next 10 to 20 years.
Thanks. We have another question here, so I'll bite my tongue, but I really appreciate the question and I really appreciate the answer. Thanks, mate.
Mm-hmm.
Oh, that was the same. Any more folks going once? Dr. Molnar.
Yeah, this is all wonderful. I would like to add a question to that. The one thing that you said multiple times is that 1 out of 3,000 prospecting jobs somehow will lead to an active working mine. And so these are, you have outlined 3 steps from the prospector to the exploration company to the mining company. So that would put this into 3 different steps. And if they're equally in chances, it's about 14. So 14 to the power of 3 is about the 3,000. So how does this actually look like then? Let's say on your level of the exploration company, I think that's where you were mostly active. How do you deal with that? And when do you decide, oh, we are taking this on from a prospector? And at what point, how often do you think we should stop, we should move on? What are the criteria? How does this feel?
Yeah, it's hard. There's just a lot that goes into it. I recently left Hercules and was interviewing with a lot of people, and I've actually taken a job now with Rangefront Geological Services. But one of the things, they all wanted me to reproduce the success that we had at Hercules on their project, as if I had some magic power to look at their deposit and go, yes, and here's, you know, a massive copper deposit for you, and a major company is going to come in with millions of dollars. And you do the best you can. And I try to look at every project and assess the viability of it. And then you make a time frame. And what I like to do is you set a series of sort of like go, no go decision points, right? And if you say, well, we're going to drill these 5 holes, and if they come back with nothing, then we shut it down, right? And we try to get rid of the project, or maybe it's 10 holes, or maybe it's 20, right? There's going to be a lot of drilling before you get things right. Sometimes it's, you're looking at things. I met some guys in Canada that have a really good looking prospect. Everything is right, but they don't have any money, and they don't, they're in the prospector stage, and I wasn't in a position to give them $150,000. I just didn't have it laying around. But it was one that I liked, and I've championed it and to a few people, and hopefully somebody will invest in their project because it looks good, and it looks good based on 100 variables of the rocks that they have, the work that exists on it, the location of it, the land package, the relations that they have with First Nations already, the accessibility. Every project is different, and they have to all be treated on a case-by-case basis. And yeah, there's a lot that goes into it. So yeah, you kind of set targets, and if you don't hit the points at some point, you got to learn how to kill your deers. And you put a lot of effort and time and blood, sweat, and tears into these things, and sometimes they just don't go, and you just have to know when to cut ties and walk away. And it doesn't mean that it's impossible. Maybe somebody smarter than me is going to come along, and they're going to make a deposit out of it, right? And there's a lot of promoters too, where they'll take a garbage deposit and they'll promote it, and they'll make it sound good. And that's the thing you got to watch out for as well. But you try to put the BS meter on and see through all that stuff and take each one as they come.
Thank you. Is there any other question in the room? We still have a few minutes time if you want to take that. I don't think there is a question. Here is another question. Let's go for that.
Okay, so you were talking about prospecting, and that's 1 in 3,000 chance of actually developing into a mine. So once you get to the junior miner phase, I guess, what are the chances there? And you said prospecting is kind of one of those things where it's kind of in the hope of the human heart. Is that still kind of a profitable side of the business where people can make like a good career, or is it kind of, is there a huge barrier to entry where there's not enough people going into that now because it's not profitable for them?
Oh, that's great. Yeah. So it's really exploration projects. It's not just every like prospector project. It's really every of the exploration projects at all stages. It's sort of your 1 in 3,000 chance of success. But the prospector, world is interesting. And I've met prospectors across the board where I've met folks that are in their 20s and they go out every weekend in their summer. And that's what they're doing. They're working on these gold prospects. I've met people in their 30s and 40s who have made a career as prospectors and have a good life. I knew a guy, if the gold was too small, he just let it go into his settling pond and ignored it. And I basically was like, I just want to like buy your settling pond from you because it's going to be full of gold. And I've known people that have gone out and treated it like a job. We were in Alaska at this one project, and this one fellow who was very successful. He went out every day. He had his equipment out there, and it was his job. He went out and did it for 10 hours a day or 12 hours a day, and as long as he could, and made a fair amount of money. And then I knew other guys. We had this one fella who, you know, drove around with a bottle of Crown Royal and bombed around these old mining roads with his dog and poked away at stuff, and had his buddy come up and they had a machine gun and they'd get drunk and shoot into the wall, and they'd mine a little bit here and there, and he wondered why he wasn't getting rich, right? And, you know, every type of person you can imagine is doing this sort of thing. And no, the barrier to entry is really low. All you got to do is have a couple $100 to stake a claim, and you go out there, and theoretically you need that and the knowledge to know what you're looking for. But no, there's lots of prospectors, and lots of them make good livings at it, and lots of them get projects and sell them. I know a fella who there's mines named after him because he was the person that found them. And he's in his 70s, and he's a hoot if you get a chance to talk to him. And you know, he's been doing his whole life, and he's had a very good life with it.
All right, I think we're right at time, but I think a crucial question, follow-up question is, the gentleman who was consuming the Crown Royal and not making a success, is that because he was spending too much money on the Crown Royal, or like he was buying an inferior product and it wasn't providing the appropriate level of inspiration, Chris?
Well, as a former bartender, I'll defer on that one. But yeah, no, he definitely was a good guy. But yeah, they got up to some weird shenanigans. And I think that the amount of Crown Royal had more to do with the lack of success. There was an inverse relationship there.
Thank you so much, mate. Folks here, please join me. One more round of applause for Chris. That was a really awesome talk.
Oh, thank you. And I'm sorry I couldn't have been there in person. I really wish I could have. But
we're going to find a way to make that happen before too long. I'm going to hand you back over to Dr. Molnar. No, okay. I think, folks, if there's anyone in the room that's got questions for Dr. Molnar and myself, please come and grab us. Otherwise, get while the getting's good. We will see you all on Thursday. And Chris, I think you should head on to your next adventure of the day. But thank you once again, mate. That was absolutely magical.
Oh, thank you. I really appreciate you. And
thank you, Chris.
It
was awesome. Thank you so much.
All right. Thank you.